Okay, I'd like to welcome you to Math 143, Section '05. And we meet on Mondays and Wednesdays at 2 to 3:15. Yes, 2, excuse me, Tuesdays and Thursdays. And I want to just talk real quickly about what the topics are that we're going to cover this semester. So the first type of problem that we're going to be looking at is the following. You have two situations where, let's say that you produce three types of pet rocks: the cheapo, the mediocre, and the deluxe. And you make $3 on the cheap pet rock, $2 on the mediocre, and $5 profit for each deluxe pet rock. And believe it or not, back in the, I think it was the 90s or 80s, somebody actually came up with this goofy marketing plan of selling pet rocks. So you make $3 on this one, 2 on this one, and 5 on this one. And you would think, well, because this is $5, this is the one I should make the most of. The problem with that is that you have limited resources. So for example, let's say you have 55 gallons of bait, and let's say you use 2 gallons on the El Cheapo model, 3 gallons of paint on the mediocre, and 4. So you're using more paint for the the deluxe model, and then you have I don't know, 200 hours worth of work that's available, and so you have all these different constraints. And so the question is, how do I maximize my profit but not exceed my limited resources of 55 gallons of paint and 200 hours on some kind of a machine, let's say. The flip side is minimize cost. So you produce these three things, and you have now what are called quotas. There's a contract that says that you have to produce at least 10 Abram tanks. You have to produce at least 3 something. And notice that the inequalities have flipped. So that's about 1/3 of the semester. The next 1/3 of the semester is money problems. And I don't mean lack of money, which we all have. Typical types of problems is you can put into bank $150 a month at such and such an interest, and how much do you have at the end of 3 years? Or you graduate from UW Whitewater, you get a really good job, and you want to buy a house. So the question comes up is, okay, this is how much I can pay per month. That tells you how big of a house how much you can spend on your house payments. Those are the types of problems. And then the third part of the semester is going to be basically probability problems. Let's say that you sell a package of 12 pens, and on average, let's say 2 pens are defective. So if a customer picks out 4 pens at random, what's the probability that at least one pen is defective and 3 are okay? Now the reason for this is obviously quality control. You want to know, if you're in business, you want to have some idea of how many products are defective, and how does that affect your bottom line. So that's a really quick overview of the course. So I'm going to get started on section 1.1, and let's say that you make $15 an hour, and you get a one-time bonus of $50, let's say for gas, whatever. And so what you'd like to do is come up with a nice, succinct formula for that situation. So we have 2 things that are going on. There's the amount of money, the dollar amount, and the time worked. So we're going to have 2 variables here, T's and money. And so if you work 0 hours, you take $15 times the amount of time that you work, plus your bonus, which is 50. If you work 1 hour, and we're not talking about anything like taxes or anything like that. So if you work 1 hour, 15 times 1 plus 50 is 65, etc. So you have two choices here. And remember from college algebra, you could put dollars here and time here, or you could put time here and dollars here. Now, what the standard assumption is that this column is the independent variable, and this column is dependent. When you think of it this way, you're saying this column of numbers depends on this column of numbers. This column of numbers depends on this column of numbers. Now, if you look at this representation, I'm saying 0 depends on 50. The time depends on how much money I make. Yeah, but that's kind of clunky. So let's take a look at this one. The amount of money I make depends on how much time I work. Ah, that makes more sense. This is the one that you want to use. So this is going to be your quote X column. This is going to be your Y column. This is the dependent variable. This is the independent variable. The amount of money you make depends on the time that you work. So we could take this information and put it into this table right here. So if you work 0 hours, you make 50. If you work 1 hour, you make 65, etc. So we have a pair of numbers. So what we do is we put the time axis here, your quote x-axis, and your y-axis is the amount of money. So 0, 50 just means don't go left or right, go up 50 units. Now obviously this is not the scale. Work 1 hour, you get 65, 2 hours, you get 80, etc. And so you could put all this information together. I'm sorry, the humidity is so high that the papers are sticking. So you could plot this. So when you have pairs of numbers, I'll pull this down just a little bit. So if you have pairs of numbers like 0, 3, -5, 0, -2, 3, 0, 0. So you're thinking of this as like an atlas, a map, where you're trying to find, this great Chinese restaurant on, blah, blah, blah. Or you're trying to find a particular town that says J7. So you find the J and then you find the 7. And it's the same thing here for Cartesian coordinates. So the number -5, 0 means move over to the left 5 units, don't go up or down. 0, 3 means don't move left or right, go up 3 units. -2, 3. This is wrong. Sorry. Let's just make that. Let's just make that 2, -3. Sorry about that. So 2. Not doing too good here. 2, -3 would be down here. Sorry. So you're moving over 2 to the right and 3 down. 0, 0 means you're at the origin. You don't move left or right. You don't go up or down. And so that's how we calculate or plot points. So the first number is the independent variable. The second number is the dependent variable. So this is your independent variable. This is your independent variable. This is your dependent variable. Now we have to talk about distance between points. So suppose I have 2 points, 1, 5 and 4, 5. So you'll notice that the height, the y value is the same, 5. Since it's only the x that's changing, how do I figure out the distance from here to here? I just take 5 minus 1, which is 3. All right, and if we talk about vertical, 2 points above each other, we do the same thing. So in general, if I have the same y value right here, the only things that are changing are the x's. So we just, to calculate the distance, we just take the right one from the left one. So it's x2 minus x1. Now if we have 2 points which are directly above each other. So in other words, they have the same what? X. You move over 4, you move up 5. You move over 4, you move up 9. So how do we calculate the distance? Well, you just take the what? Bigger y minus the smaller one, 9 minus 5. So in general, if you have 2 points that are directly above each other, that is, the x values are the same, you just take the difference in the y values, y2 minus y1. And then you remember from high school geometry that if I have what's called a right triangle, that is, this is 90 degrees, then it turns out that these numbers can't be just arbitrary. You can't make this a 6, this 10, and this, 100. It doesn't make sense. So it turns out, and you may or may not have seen the proof of this, that if you square these sides and add them up, this guy has to be the square of the sum of these two guys. And since we're interested in the distance between these two, I don't want c squared, I just want the what? The square root of that. And theoretically, you should have a plus or minus, but because this is obviously a positive number, we're going to take the, obviously the distances are not negative. So to take an example, suppose we go back to the points that we had 1, 5, 4, 5, and, excuse me, this guy is 4, 9, and we want to find this distance right here. So we don't know what that is. So what does Pythagorean's theorem tell us to do? We have to know the distance here and the distance here, square them, add them up. So that's what we do. We take this distance between these two. So remember, this point is directly above here. So we take 9 minus the 5. This is directly to the right of this guy. So we take 4 minus 1, which is 3. And so I just substitute. So I take 4 minus 1, square it. 9 minus 5 squared. So this becomes what? 3 squared and 4 squared, which is 9, and 16, which is 25. And that turns out to be the square root of 25, is obviously 5. And your distance formula then is just, you take, how do you find the distance to two arbitrary points? Well, let's say that we have an x1 and a y1, and we have an x2 and a y2. Now, how do I find the coordinates of this point, which is directly below this one, and directly across from this one? Well, notice, to get to this point, I go over this distance, which is my x2, and then I go up the y1. Let's take a look over here. Does that make sense? This x value is the same as this one, makes sense. The y value, though, this is the upper one, this is the lower one. So the distances are just going to be what? The difference in the x's squared, difference in the y's squared, take the square root. And these formulas will be given to you for your on a formula sheet, so you don't have to memorize them. But most of you have probably seen this stuff already many times. And so if I give you two arbitrary points, -3, 2, and 9, 7. Now what I strongly suggest is, my friend, when we get to the slopes in the next section, I want you to draw really a rough picture, just to get an idea. Because when we talk about slopes, this is going to be a positive slope. So if you calculate this slope, you get a negative number, you know you did something wrong. So the distance between these 2 points, what do? You take the rightmost x minus my leftmost. So I take my 9 minus, be careful, a -3, and then I square it. I take the difference in the y values, 7 minus 2, square it. So 9 minus -3, remember this is inside and being squared, so this becomes 12 squared. 7 minus 2 is 5 squared. So 12 squared is 144. 5 squared is 25. and if you add them up, you get 169, which turns out to be a perfect square. And so you could take the square root of 169 is 13, and that's how you calculate distances. And that is it. I can't drag that out any further. That is the distance between 2 points. And we're now going to go to, so this part, this section, these topics here in chapter 1, everybody has seen these over and over and over again, so I don't want to waste too much time on them. The next topic is for section 1.2, and that has to do with straight lines and how you construct them, what do they mean geometrically. Now, let's consider the roof lines, okay? So, if you've ever been to Phoenix, most of the houses, their roofs are very flat because Phoenix is not known for snow. In South Carolina, they don't get much snow, but maybe they're a little bit, they have a little bit of a slope. Illinois, well, they do get snow. Here in Wisconsin, maybe you have houses that, some of these really older houses have these huge slopes. So whatever definition we come up with for our definition of slopes, we all agree that this is steeper than this is steeper than this, and this is not. This doesn't go up or down. So the slope is probably going to be 0 for this one, and it's going to be a larger number here. So we ask the question, how do we define the concept of slope? And we have to remember whatever definition we come up with has to reflect these roof lines. This slope has got to be bigger than this one, this is bigger than this one is 0. So here's how we do it. Let's take a look at the South Carolina. So it means if I move over 1 unit, feet, yard, whatever, and I go up half a foot, then I'm going to just play a game. I'm going to take this number divided by this number. So 1/2 divided by 1 is 1/2. Now let's look at Illinois. If this is 1 and this is 1, although it doesn't look like that, I apologize. If we take the ratio of this number to this number, 1 over 1 is 1. And then if we look at Wisconsin, suppose we move over 1 unit and we go up 2 units. 2 over 1 is 2. And these numbers match up with our intuition. In fact, if we look at the roof line in Phoenix, if we move over 1 unit this way, we don't go up or down. The height is 0. So 0 over 1 is obviously 0. That makes sense. So what we've got is the following. So we looked at the distance between 2 points. So we had a point x2, y2, x1, y1. And we found out that the distance from here to here is the difference in the x values. And the distance from here to here is the difference in the y values. So that's how we're going to define the slope. Is we just take the what? The change in the elevation divided by the change in the horizontal. Rise over run. Probably heard that a few times. So what happens though if the line is vertical? Now what do we mean by vertical? It means this point is directly above this one, or this is directly below this one. Notice that the x values are the same, the y values are different. So if we take the difference in the y values, 11 minus, and it doesn't matter which one you take as your first point and second point, and 3 over 3, you're going to get 4 over 0. And if you try to put that into your calculator, it's going to say undefined. And the question comes up is, why is it undefined? And there are several ways to look at this, but I want you to think kind of geometrically and mathematically. So the question comes up, I have no idea how to calculate 1 over 0. Now, probably your, fourth grade teacher, third grade teacher, Mrs. Graves, whatever, told you that it's undefined, but maybe didn't explain to you why. In this course, that's not good enough. There's a college course in mathematics. You really should know why something happens, not just it was just some arbitrary rule. I'm going to play a little game. What I'm going to do is I'm going to approach this by taking 1 over a small number and see what that does. So the first number I take for the denominator is 1. Well, 1 over 1 is obviously 1. Let's take 1 over 0.1. So I'm making the denominator small, because 0.1 is really 1 over 10. And if I take the numerator and think of that as 1 over 1, 1 over 10, you've been taught that when you have a fraction over a fraction, you're supposed to invert and multiply. I'll talk about why that's done, okay, in a few seconds. So if I invert and multiply, I get 10. That's definitely bigger than 1. Let's take a look at 1 over 0.01. That is 1 over 1/100th. Again, the 1 on the top is 1 over 1, 1 over 100. And then we invert and multiply, and you get 100. So the point of this is, if you take 1 over a very small number, you get a very big number. In fact, 10, 100, 1,000, 10,000, etc. Those numbers are diverging. They're going to infinity. We have another problem. If I go from the negative direction, so in other words, I'm going to make the numerator approach 0, but I'm going to make it from the negative. So 1 over negative 1 is obviously negative 1. 1 over negative 0.1 is negative 10. Same reasoning. 1 over 0.0 minus 0.01 is 1 over minus 1 over minus 1 over 100, which is minus 100. Notice what's happening is these numbers are approaching what? Negative infinity. You have two problems. When you make the denominator small but positive, you're approaching positive infinity. When you make the denominator small but negative, you're approaching negative infinity. So from an algebraic point of view, you've got a problem. But let's take a look at this from a geometric point of view. Remember our roofs. So if my roof is starting to get steeper and steeper and steeper, the slopes are getting big in the positive sense. You'll remember that if the line is like this increasing, then your slope is positive. If we look at the other side, so we have negative slopes, notice that this one is not as steep as this one, is not as steep as this one, etc. So these are going to minus infinity. That is the geometry of why we do not divide by 0. So, by the way, I get a question. You've been taught, that when you have a fraction divided by a fraction, you're supposed to invert and multiply. Question, why is that? Well, here's what I'm going to do. Today's Thursday, so what I'm going to do is I'm going to take this and I'm going to multiply by 1, disguised as 6 over 5. 6 over 5 divided by 6 over 5 is 1. Now, why did I do that? Not because it's Thursday, but for the following reason. What happens when I take 5/6 times 6/5? The 6's are going to cancel. This is multiplication, right? And 5 divided by 5 is 1. Upstairs, you're left with 3/4 times 6/5 divided by, which is 3/4 times 6/5. That's why when you have a fraction divided by a fraction, that's why you invert and multiply. Now, you remember that if I have two lines that are parallel, it means their slopes are the same, right? So if I have line 1 with slope 1, please don't ask me why they use the symbol M. I have no idea, okay? And if m sub 2 is the slope of the second one, and if they're parallel, that means the slopes have to be the same. Now you remember you can also have what are called perpendicular lines. That is, they meet at a 90-degree angle. Now I want you to notice something. If I look at this slope, it's positive, and if I look at this one, it's negative. And no matter how I orient those two things, except like the vertical, right? So no matter how I orient it, one of the slopes is always positive and one is always negative. So if one of them is always positive, one is always, then you have to have a negative number. And I want you to notice that if this slope is 1, it looks like this is a negative 1. It's not a proof, it's just an observation. And if you make this one steeper, the other one goes like this, and so you could have a big number times a small number. And I'm not going to prove this to you. You have seen this, that two lines are perpendicular to one another if one is the negative reciprocal of the other. That's one way you guys may have seen it. If I multiply both sides by m sub 2, then I get m sub 1 times m sub 2 is equal to negative 1. So here's your test to find out if two lines are perpendicular. So let's take some examples. So remember you're making $15 an hour. You get a $50 bonus, and this is how much money you make. So if you think about this, we plotted some lines. So 0, 50, 165, 280, and we can figure out what the slopes are. So I'm going to just take the difference in the y values, the difference in the x values. So I take 80 minus 65, and then 2 minus 1. And remember, it doesn't matter which way you do this. Just stay consistent. So 80 minus 65 is 15, 2 minus 1 is 1. The slope is 15. Guess what, folks? This number right in here is this number right here, this slope, that's how much you make per hour. So in this particular example, the slope has a meaning. And if you let the t be 0, the amount of money you make is 50, and that is your, quote, y-intercept. Right, if you're thinking of these as x's and y's. So you'll recall from high school algebra that we call the equation of a line in this form, it's called the slope-intercept form, because you have the slope and you have the intercept. And again, the intercept is because if the x is the t is 0, the x is 0, the y is equal to b. So this is your y-axis, and that's your y-intercept. Now a question comes up is, suppose we have the following information. I'm told what the point is on the line, that there's a point, and I tell you what the x value is and the y value on this line, and I also tell you what the slope is. And the question is, can we come up with the equation of the line passing through user-specified point and user-specified slope? And here's how we do this. We do the following. Any point on this line has the coordinates x comma y. And you know these two numbers, and you also know the slope. So let's put this into the slope form. So you take the difference in the y. Now, we don't know what the y is and we don't know what the x, but we do know they lie in this line. So they have to have this slope. So if I take y minus y1, x minus x1, that has to be user-specified. If I cross-multiply, so I don't work with fractions, I get m times x minus x sub 1, y minus y sub 1. And I'm just going to flip the equation. And this is called the point-slope form that you've seen in high school. And all it is, the reason why you call it is why. You're given the coordinates of the point, and you're given the slope. That's why we call it the point-slope form. Okay. So let's take some examples. Now what I'm going to be doing throughout the course is in your homework, you are going to be, excuse me, the homework problems are almost always going to be the odd problems.